Hi again everyone, Chris Tisdell here again. In this presentation I'm going to continue my series of videos that give a gentle introduction to the mathematics of vectors. Now in previous videos I motivated our study of vectors, I gave geometric and algebraic treatments of basic operations involved with vectors, addition, subtraction, scalar multiplication. In this presentation, I'm going to discuss how to calculate a vector from one given point to another given point. I'll discuss the geometry and the algebra associated with it. So let me get underway and let me share my screen with you. Now, I've just started off with a basic concrete example. Suppose we have 2 points A and B. A is the point 1, 2, and B is the point 4, 3. I'm just working in two-dimensional space here, or the XY plane. And the question is, what is the vector from A to B? Okay, well, we would denote that as this vector here with a little arrow above it, the vector from A to B. That's the focus of this particular presentation. So what I'm going to do is draw a little diagram over here. So the first thing I'm going to do is put the points in. So I'm going to plot the point 1, 2. That'll be here. And I'm going to plot the point 4, 3, which will be up here. Okay, so what we're trying to get a representation for is this vector here. Okay. All right. All right, big chunky vector. Okay. So how do we do it? So this is the point A, this is the point B, and this is the vector AB. What we're trying to do is to write AB in either a column form or an IJ type form. Okay, so geometrically it's easy to draw the vector AB, but can we calculate it? Well, one way of doing this is to actually compute the position vectors for the points A and B. Now remember, a position vector is a special vector that has its tail point at the origin and its head point at the point of interest. Okay, so that would be the position vector of the point A. That's the position vector of the point B. Okay, and this little O denotes the origin. Okay, so in previous videos we talked about the triangle rule for addition, or the parallelogram rule for addition. They're the same rule. Essentially, this vector plus this vector is equal to this vector. Okay, so if I write that in terms of, say, points including the origin, then you'll see that this is that this follows, even if you can't remember the geometry of the triangle rule. If I put my finger over these two inner letters here, I get OB. Okay. All right. So these lowercase boldface symbols are the position vectors of A and the position vector of B, respectively. And that just means the vector from the origin to A, the vector from the origin to B. Okay, so what I want to find is the vector AB. So if I rearrange this by taking this to the other side, then I get the following. The position vector of B minus the position vector of A, or written in terms of the tail point and the head points, it would be this. Now, I know what the position vector associated with A is, big A, we can just write it as this column vector. And I know what the position vector of big B is. It's just this column, or basically this point, written as a column vector. Now, when you're adding or subtracting column vectors, you just add or subtract the corresponding component. So 4 minus 1 gives you the first component, is just 3. 3 minus 2 gives you the second component, that's 1. Okay? Now, if you wanted to write this out in terms of, say, i's, j's, and i's and j's, it would be something like this. Let me see if I can squeeze it in. Okay, so this is 4i plus 3j. So this is in terms of the basic unit basis vectors, or minus 1i plus 2j. Okay, so again you add or subtract the corresponding components. 4i minus I is just 3i. 3j minus 2j is just j. Okay, now I'm giving you both the column forms and the I and j forms because you need to know both. Okay, different textbooks, different teachers use this, and they may swap between the two. Okay, so the important thing, if you apply the triangle rule, come up with this, and this is how we apply it, just through simple component-wise operations. Okay, so for a bigger picture, let's talk about how we compute the vector from one point to another point. Okay, and in this setting, the vector A is just, OA, if you like. So this. OB is this. So these are the position vectors of the points in question. Okay, so big A would have components A1, A2. Big B would have the components B1, B2. Okay, the vector from A to B is the following. Now in component form, as we saw up here, this is just the following column, or in IJ form, it's just okay. So that's pretty much your bases covered. If we were working in higher dimensions, here we're working in 2 dimensions, but if we were working in higher dimensions, we would just have more, like a longer column here and more components. Or instead of just i's and j's, we would have I, j's, and k's. You would just keep this going, okay, the differences. Now, if we wanted to compute the length or magnitude of the vector AB, then after computing the vector AB, you just look at its length or magnitude. Now, we looked at a formula for computing the magnitude. Essentially, if you have, say, a position vector and you square each component, add them together and take the square root using Pythagoras' theorem, then you come up with the length. So with this one, the first component of AB is this difference, so it'll be B1 minus A1 all squared plus this all squared. Okay, and if you had, again, 3 dimensions, you would have another part in here. Okay, so if I was going to compute the length of this particular vector up here, or the magnitude of it, it would be the square root of 3 squared plus 1 squared, which is root 10. Okay, so that's the basic concept to determine the vector from one point to another point. After you've given the points, write down the position vectors, say as columns, and then to compute the vector from A to B, you will take the position vector of B and take away the position vector A. Okay, so a very brief and short lesson today about determining vectors from one point to another point. If you have any comments or questions, your feedback is always valued, and I hope you can join me for the next installment in this series, An Introduction to Vectors. I hope you can join me for the next one.